Hello, kicking off the 2014 Matt. So as usual, that means the multiple choice questions. We got 10 of them at the beginning. Question A, this inequality, we just need to solve that inequality. X to the power 4, okay, but that might not make any difference if it still factorizes in x squared. So x to the 4 minus 8x squared minus 9 less than 0. And yes, that does factorize because we're going to get a minus 9 and we're going to get an x squared plus 1. That's always positive, so we need that to be negative. So we need x squared minus 9 to be less than 0. So x is going to have to be between minus 3 and 3. Okay, usual easy starter. Question B, the graph of this function is sketched where? Okay, so yeah, a bit of an ugly looking thing, but we'll say, well, let's do our usual x is 0, y is 0 option. So when x is 0, we've got y is log base 10 of 2. So somewhere between 0 and 1. So it could be A, could be B, can't be C, can't be D, could be E. Then we've got for y is equal to 0. So that would mean that the bit in brackets would have to be equal to 1. So we've got x squared minus 2x plus 2 is equal to 1. Take the 1's off. X squared minus 2x plus 1 is 0. So yeah, that factorizes. X minus 1 squared. So x is 1 when y is 0. So not A, not B, E. Okay, all good. Question C, we got a cubic. It's got a turning point as a minimum when x is 1 for what values of k? Right, so differentiation time. Y dash 3k x squared minus 2k plus 1x plus 2 minus k. Do that again. I'll leave a bit of space in case I have to do anything with that. 6k x minus 2k plus 1. So when x is 1, we're getting this y double dash is going to be equal to 6k minus 2k minus 2. And we need that then to be greater than 0. So that's one thing. We got 4k is greater than 2, k is greater than a half. So it's already pushing us to C. When x is 1 here, what we're getting, just to make sure it is actually a turning point. So 3k minus 2k minus 2 plus 2 minus k is equal to 0. So we've got 0 equals 0. So that checks out. K is greater than a half. Right, it's going to kick in soon, I'm sure. Okay, D. So the reflection of the point 1, 0 in the line y equals mx has what coordinates? Right, let's get a bit of a sketch, leaving enough space down the bottom for the working out. So we've got that. We've got some point there at 1. We've got some line y equals mx. We're going to be going perpendicular to that. Same distance the other side gives us the reflected point. So we need to know where that is. We've got a number of options here, I suppose, haven't we? Because we've got those similar triangles or identical triangles going up to there and up to there, making that kite. So we could do something off of that. That might be quite interesting, actually. We've got some rather tedious algebra we could do off of this. Actually, we've got a real cop-out solution here. We can say, well, that side is 1 as well. So our coordinates of this point, if we got some angle here, theta, then our coordinates up here are going to have to be cos theta, sine theta. So we can then say that we need, whatever the answer is, to fit with x and then the square root of 1 minus x squared, just taking our cos sine identity. So it's not going to be B, it's not going to be C, it's not going to be E, it's going to be A or D. So we're just going to, well, let's give it a go. It gives us something to aim at. I'll probably do a different solution afterwards. So say we were doing A, we're going to get, so 1 minus x squared, we'll get an m squared minus 1 squared minus an m squared plus 1 squared all over m squared minus 1 squared. So and then we have to square root all of that. So the yeah, the denominator is going to be fine. The numerator, the m squareds, the ones, they're all going to cancel. So we're going to be left with a minus 4m squared on the top, which is not going to reduce to that. So it's not going to be a. But you can see how we won't get the same problem with d, because we'll still have the 1 plus m squared at the bottom when we've square rooted it. But then we're going to have the square root of 1 plus m squared squared minus 1 minus m squared squared. So we're going to have all of that, which means that we're going to have again, the 1's and the m squareds are going to cancel when we expand that out. But we're going to have a 2m squared, 4m squared, square rooted down to 2m. So it's going to be D is our answer. But that's, like I say, a little bit of a cop-out. Maybe we should try one with these similar triangles then, because that could really help matters, couldn't it? I think if we do that. So because we got a really nice setup with this bottom triangle. If we take that bottom triangle like this, so that's going up to 1, and we know then y is mx, so that's going to 1m up there. So that side is m, that side is 1. Let's call that, well, let's use, this is a different theta to the one that I had over there. So it's going to be half of that one, but we're doing a new approach on this. So we can say from Pythagoras, that's going to be the square root of 1 plus m squared that we've got there. Then we can take another triangle. So when we do the up to the point on the line, so if we've got this, so that's now our side m, that's the point 1. We're now going up to our right angle there. And this is going to be the same, so this is going up to that point on the line y equals mx. So this side here is on our y equals mx line, because that angle there is going to be theta. So we've scaled this triangle. It's a similar triangle, but we've now scaled the sides, haven't we? So what was a 1 here on this side, on this original triangle, so the one next to the angle theta, is now been scaled, so that is going to be m over the square root of 1 plus m squared, because that's the same scale factor as we got on the hypotenuse. So we can take that, and then we can do another triangle then off of this, where we can go across, down and down. So we'll keep this same side here, so that's still theta. This is our m over the square root of 1 plus m squared. And then we can see how we've scaled the other sides then. So, well, this side, let's fill in this side that we've got up here, because that's going to be scaling this m by this factor. So that is going to be m squared over the square root of 1 plus m squared. So we've got that, if that's going to help. So we've now got a new scaling of this m. So we're taking that, we're just multiplying by the square root, 1 over the square root of 1 plus m squared in order to get the hypotenuse on this. So this was originally this side here, this vertical side, was originally our 1. We've now scaled it by that, and then we've scaled it by that bit. So that's going to be m over 1 plus m squared. So that's what we've got for that side. And then our x side, which was originally an m, is now going to be that, well, scaled by this thing again. So that's going to be m squared over 1 plus m squared. So now we're doing this twice. This is what makes this interesting, because that gets us from our point 1, 0 here up to the point on the line. We have to do exactly the same triangle to get to the other point. So our y coordinate of the reflected point is going to be twice this, twice that side. So it's going to be 2m 1 plus m squared because we were starting from 0. So that's given us that y coordinate. The x coordinate is going to be equal to 1 minus 2 lots of m squared over 1 plus m squared. So that is 1 plus m squared minus 2m squared over 1 plus m squared, which is 1 minus m squared over 1 plus m squared, which is our x coordinate. So those similar triangles work a treat on this. So I'd say that is a much more satisfactory way of working it out to this second method in order to get D. But we do have this cop-out solution. We do have the sort of trial and error option just based on this identity between sine and cosine. So yeah, that's an interesting question. Very interesting question. Enough of that. On to question E. As x varies over the real numbers, the largest value taken by that function equals what? Right, okay. I mean, we're squaring something here. I'd be surprised if it's any of the ones that have got thirds in. I mean, I suppose you never know, but it seems highly unlikely. So I reckon this is going to be B or E. And it doesn't look as though it's going to be E because we're not going to get sine and cos to be 1 at the same time. So it's not going to be that because the largest that can be is 4. Largest that can be is 4. So if they were both 1 or minus 1 at the same time, then you get 9 squared. But we can't get that. So it's not going to be that. I think it's going to be B. How are we going to show that it's B? I mean, we could differentiate. Because differentiating sine squared isn't that difficult. We're just getting a sine, well, 2 sine x cos x product rule and all that. But I reckon maybe replacing that. So if we replace that with a 1 minus sine, 1 minus cos squared, so we'd get 4 minus 4 cos squared, and then we got everything in cos. If we can factorize this, then this is going to go well, I think. So particularly as I reckon we're moving towards wanting to have a 6 in all of this. So I'm going to try doing that with a 6. Because we've got 5 already. So I'll make that a 6. And then minus 4 cos squared x plus 4 cos x and then a minus 1 all squared. Right. Yeah, this is moving towards it because we're taking off a square. So we're going to want that to be 0. So let's make that a big bracket. So 6 minus, and then we can say 4 cos squared x minus 4 cos x, and then plus 1, and then that's squared. So we want to then factorize this, which hopefully, so what's that giving us? 2 cos x. And we'd have to have something negative. Would -1, is that going to work if we just square that? That would solve all the problems. We'd have 4 cos squared x, we'd have a plus 1, and we'd have a minus 4. There we go. So, and then a 6 minus that squared. So the most we can make that is when that is 0, because then we're taking nothing off of 6 and then squaring that for 36. Okay. Yeah, it just seemed highly unlikely that we were going to have something inside the bracket that was going to be a 4th root of something. So when we square it, I suppose we could have had terms. Yeah, we could have had not this one. That would have ruled out this, but not these, because yeah, of course we could be getting we could be squaring it in some places and not in others. So yeah, maybe I shouldn't have been that quick to rule those out. Although it helped, weirdly enough, that it did help point towards making that a 6 in there. But we still could have factored this anyway. Okay, I feel a little bit guilty now that I've managed to get an ill-gotten gain there of a shortcut towards the right answer that was actually a incorrect shortcut. But if we hadn't have done that and we just left it, so say I had been at 5, we could have done the same thing. So do a minus 4 cos squared x and then minus 4 cos x. Then try and factorize what we've got there. So you're still going to be going to a 2 cos x and then minus, well, you're going to want the minus 1 squared and then we'll take the 1 off in order to get that. So you're still going to end up in the same place if you can factorize that. So yeah, I don't have to feel quite so bad about that. Right, on to question F then. The functions s and t are defined for real numbers by s is that and t is that. Function s is applied s times, function t is applied t times in some order to produce that function. It's possible to deduce that what? Right, okay. So we start with x. Well, we have to do s at least 8 times. Otherwise, we're not going to get up to 8. That's the only way we're adding numbers on, isn't it? And we have to get up to 8. So, I mean, s could be, if s was 8, we'd get to x plus 8. And then, but if t was 1, that would make it a minus 8. So we can't do that. Yeah. So anyway, it's not a. Then, I mean, we must be able to make this. So t is just flipping backwards and forwards. So we go minus x, then we go back to x. If we had done an s in between, we do an x plus 1. And then we go to a minus x minus 1. Then we can enter minus x. Oh, wow, you can end up going all over the place here. But we must have had, so is t even, s even, odd? Well, t must be odd, because otherwise we're not going to end up with a minus x. So that's one thing we can say. Yeah, t's going to have to be odd, because we're just going, every time we do t, we flip the sign of x. So we need a minus x. So we have to have t odd. So t is odd. So it's not going to be b, and it's not going to be d. So it's either c or not at all. But we must be able to do this, mustn't we? Because we can do, if we start with x, do a t, get a minus x, and then just keep on adding s's. So you could do 1t. Oh wow, this does work for a. That does work for a. I hadn't thought of that the first time round, because now we do add on a whole load of those, and we've got 8 minus x, and we've done, oh right, so is this back on the table? Oh, but we could do as many t's as we want. Well, as providing it's odd, we could do 3 t's. So we don't know that t is 1. So yeah, it's still not a. But we could have, well, we can, it's definitely not none of the above, because if t is odd and s is even, but s has to be at least a. 8, not a. There's no a in it. It has to be at least 8. So yeah, it's got to be c. It's the only one that's left, because we know we can produce it. We could do s is 8, and then t is 1, 3, 5. It doesn't really matter how many. Or we could have s is even more than that. We could do s is 10, and then t would have to be, yeah, okay. We've got lots of combinations, right? I'm happy that that's going to be what it is. That it's going to be c. So a little bit trial and error on, well, a little bit trial and error, a lot trial and error on that one. Right, G, let n be a positive integer. The coefficient of x cubed y to the 5 in the expansion of this equals what? Okay, x cubed y to the 5. So we need to be combining at least those. I mean, we can throw ones in as well. Obviously, it doesn't hurt. So when do we get our first one then? We need at least 3 of those and 1 of those. So we need n to be at least 4 before we get anywhere. So n is greater than or equal to 4. When n is 4, what we getting? So n is 4, we'll get 3 of those and 1 of those. So we've got 4 brackets, and we need to pick 1y squared. So we've got 4 different ways we can do it, because we can take the y squared from any of the brackets. So we've got that as a setup. So it's, well, it could be A, it's not B, it's not C, because that's going to mess things up. It could be D, and it's not going to be E. Right, so we're already down to A and D. Then, well, we also know, though, if n is 3, then the coefficient has to be 0. So it can't be A, and that does fit with D, because how many ways can you pick four things out of 3? Well, you can't, can you? So, yeah. So we just end up with D. There's not really much more to say about that. Okay. H, the function fn is defined for all positive integers as follows. Oh, it's one of these stupid things where you have to spot a pattern. They got more function options here, and we need the value of f6000, right? So let's build up the sequence then, see what the pattern is. So we start with, so let's do 1, 2, 3, 4, 5, 6, 7, 8. These are my n's. 9, 10, 11, 12, 13, 14, 15. If we haven't spotted a pattern by the time we got to 15, then I'll probably give up. So we start on 0 for 2. So if 2 divides n but 3 does not, okay, that's fine. So we go to the previous one and we add 2. So that becomes 2. Then for 3, so it's not the first one. 3 divides n but 2 does not. So we've got this one, we do the previous one, and we add 3. Okay. Is the pattern going to be the number? These are going to keep going up. So let's do 2 things. Well, I'm doing a +2 and a +3. So I can see which one's going to be the pattern. So for 4, we're back on the first one. So we're going to 7, 5. Right, so it's neither, it's not the first 2, it's not the third one. Right, it's the last one, because that's not divisible by 2 or 3. So it's the previous number, which is a +0. Then a 6, so that's 2s and 3s. So we do the previous one +4. So 11 +4. 7 is another one which is the same as the previous number, because that's not 2 or 3. 8 is the first one, so +2. 9s is the second one, so +3. 10 is the first one, +2. 11, that's prime, so +0. 12 is both, +4. So 22, 13 +0. Right, okay, it's quite easy to build these up. 14 will be the +2. 24, 15 will be the +3 to give 27. So we got 2, 3, 2. Oh, there's another 2, 3, 2. 2, 3, 2, 2, 3, 2, 2, 3. Oh, and 0, 4, 0, 0, 4, 0. Right, we have our pattern. Splitting these blocks of 6. So in every block of 6, we're going up by 5, 7, 11. So 11 in every block of 6, and we've got 1,000 blocks of 6. So we want 11,000, which is C. Okay, right, so pattern spotting, it comes up all the time. Graph of this function is obtained from that graph by stretches, translations, reflections. Right, so how are we getting that to that? So we want to go from 2 to the x squared to 2 to the x squared minus 4 plus 3. So we need to get this horrible power there into an ax plus b plus c, well, squared format. We need it in that format. That's all the ways we can change that x squared. We can add something to x before we square it. We can multiply it by something, and we can add on a number after squaring it. So we need it in that format. So we're going to have an x minus 2. We're going to have to complete the square on it. X minus 2 squared will be, that's our x squared minus 4x, but that gives us a plus 4, which we have to take off. And then we got a plus 3. So that is x minus 2 squared minus 1. Okay, so we've moved it 2 to the right, and then we've got a minus 1. What's that minus 1 doing? Oh, we can turn that into a half, because this is a power, isn't it? So we got 2x minus 2 squared minus 1 is a half, because we've got a 1 over 2 there, of 2x minus 2 squared. So we've moved it 2 in the x direction off to the right, and then we've squished it in the right direction. So it's not A then, so we want a translation parallel to the x-axis. That certainly looks good. And so it's not going to be E, so it's one of those. They're all the ones that got the parallel. And then we've got a stretch in the y direction, so it's got to be B. That's the one that fits with that. Okay, that was fine. I mean, a difficult transformation, but it was okay. But this doesn't look like much fun. For real numbers x, the function f of x satisfies that. Okay. It follows that this integral equals what? So we've got 6 plus f of x, 2 f of minus x, so reflection in the y-axis, plus 3x squared times this. Well, this is the same integral because, okay, I've just replaced the x's with t's, but it doesn't really make any difference. So we've got the thing that we want. Can we just solve for that? We can't solve for that because we've got this x squared thing in there, plus we've got the problems with these functions. But that's already got it done, so that's just some value. That's going to be some area. Or, yeah, so that's what we're after. But that's already been turned into a constant by having done that. So we could recreate this by integrating again, maybe. Because that is just a constant. So if we had 6 plus f of x equals 2 f of minus x plus 3, let's call it a, x squared. So we could integrate these, but are we going to get a problem then? We're integrating so it's reflected in the y-axis. So, but we're going between -1 and 1, so it's not going to matter, is it? We're going between there and there, and it does whatever it does in between, and we reflect that over. We're still going to get the same area between those 2 points because we're just swapping those around. So, yeah, that's going to work. So let's integrate then between 0 and 1. So 6 dx plus the integral of 0 and 1 minus 1 and 1 of f of x dx equals the integral from -1 to 1, 2 lots of f of minus x. And we're saying those integrals are the same, plus 3a x squared. Well, the 3a we can leave outside, x squared dx from -1 to 1. Okay, this thing we've already said is a, that thing we've already said is a. This is going to be 6x, so that would be 12, plus a equals 2a plus 3a times the integral of this, which is then going to be, well, x cubed over 3. So we've got a third, we've got 2/3. I'll multiply by the 3, so that becomes 2a. So we've got 4a, 3a is 12, and a is equal to 4, which at least is one of the answers. Right, okay. That worked out a little bit better than it could have done. So I suppose they were throwing in a bit of a curveball, I suppose, by just putting these with t's in, but it doesn't really make any difference. You know, t is still varying between -1 and 1, so we're putting all of these values between -1 and 1 into function f. So it doesn't matter if we call that t or x. We're still going to get the same outcome, the same result for the integral. Okay, that was a fun bunch. I like those. That was a tough one to finish on J, but there have been tougher J questions. That was a difficult transformation in I. That was pattern spotting. Okay, it's a long-winded pattern spotting, but it was fine. That one was, yeah, that was all right, G. It was a bit weird, but it was okay. The F, actually, the more I'm looking at these, this may be tougher than I thought. F was quite tough. E was okay, providing you can do the factorisation. D was fine if you do the quick method, but the geometry was fun. Maybe I'm thinking these were easier because A, B, and C, I think, were easier than they have been on previous papers. But all in all, it's still a challenging bunch. So if you're getting over half of those, then you're putting yourself in good stead for the rest of the paper.